Okay, 3.3, multiplying monomials. Who can tell me how many terms is in a monomial?
2.
Johnny. Mono means one. Thank you very much. But we have a couple parts of a monomial that we need to recognize. Okay, so there are several parts that we need to know. Okay, this, we call it the base. Okay, so the number that is being raised to the exponent is called the base. The exponent is the small number on top, which you all already know. Okay, but we do call this the base. So we have a rule that we're going to learn. It is called the product of powers rule. Okay, and the product of powers, what does product mean? Multiply, good. Product of powers means that we are multiplying two exponents. Now, what do you notice about the bases in this example?
They're both A.
They're both A. If we are multiplying two exponents with the same base, the base must be the same, we get to add the exponents together. Okay, so I have a quick example to show us why this works. It's okay.
That's quick.
Well, look at it. X to the fourth. That's the same as X times X times X times X. Is that correct? Okay. Times X to the third. That's multiplying X how many times? X to the third is X times X times X. Yes?
Yes.
Okay. So I'm multiplying X 4 times and multiplying it 3 times. So how many X's do I have? 1, 2, 3, 4, 5, 6, 7. So we would represent that as X to, not 7X, X to the 7th.
So basically, you're just adding the exponent.
That's exactly what we're doing. And what is 4 plus 3? 7. Okay, but I wanted to show you why we add the exponent.
Is that going to be on the quiz?
This is on the quiz.
So do you want us to show it just like that?
No, I will show you how I want you to show your work, okay?
Wait, but,
yes.
Can you go down a little bit?
Those are all of the notes. Now we just have examples, so let's do example 1. And Tommy, this is where I'm going to show you how to show your work. Okay, so A to the 5th times A to the 8th. Are the bases the same?
Yes.
Yes, so I get to keep my base, A, to the 5 plus 8.
13.
And what is 5 plus 8?
13.
Good, 13. So this would be A to the 13th. So that's how you would show your work.
How come you're multiplying but really
Yeah, let's get this.
You mean quiz?
That's what I showed you right here. Okay, so this is X to the 4th, right? Which is X times X times X times X. And this is times X to the 3rd, right? So that would be times X times X times X 3 times. Okay, so then we have X times X times X times X times X times X times X. And how would we represent that? X to the 7th. But did you notice that 4 plus 3 equals 7? So that's how we get it. Okay, that's why it works. All right? So this is how you would show your work. Yes. Brandon, that was a really good question. Okay, so let's try example 2 by yourself really quick. Yeah, how do I do this? Right, X plus to the 6 plus 4, which gives me X to the? Very good, X to the 10th. How do you guys feel about that? Really quickly, if I have a, let's use the variable m, just m by itself. That's the same, what's the exponent there? 1. Good, at 1. Okay, so if I have, say, m times m to the 3rd, what would my answer be?
M to the 4th.
M to the 4th, good. Okay.
I'm on fire.
Okay, yes.
Whatever, like, oh my God.
Good question. So what happens when coefficients get involved?
Well, how would be your next example, too?
Okay, so example 3. What happens when coefficients get involved? Essentially what we're doing is still combining like terms here. Okay, so what in this problem, example 3, are our like terms? We have x squared and x to the 7th, right? technically those aren't like terms, but the bases are the same. Okay, so we have these two guys, but we also have 2 and 3 in there. What do you think we're going to do with that 2 and 3?
Multiply.
We're going to multiply them. So my answer would be 2 times 3, which give me
6 to the
6.
6x to the 9.
X to the 2 plus 7. So that gives me 6. X to the 9. Good. Okay. Does that answer your question, Brandon?
Yeah.
Okay. So will you... All right, so Brandon, what am I going to do with the coefficients, -5 and 6?
You multiply -5 to 6.
And what do I get?
30.
Negative 30, right? Okay, and then Tommy, what do I do with the variables?
Don't you put the variable?
The y to the 4th times y squared.
Don't you?
What do I do with those exponents?
You add.
I add the exponents, so that's going to give me y to the 4 plus 2. So what is my answer, Robert?
Negative 30y 6.
Y to the 6. Very good.
Miss,
Oh.
Yes.
a negative times a positive.
Oh my gosh, you guys are so smart. You're getting ahead of me. Okay, so what happens, just like Ellen said, what if there's more than one base? We can only multiply the bases that are the same.
So like
Okay, so what two things are we going to multiply together? We have 8 times 7, right? So what's 8 times 7? 56. Okay, and then we have x squared and x to the 4th. So what's that going to give me? X to the 2 plus 4, right? And then what do I do with my y's? Same thing. Y by itself is the same as y to the 1 times y to the 3rd, so that would be y to the 1 plus 3. So we only combine the x's and we only combine the y's. So what would my answer be in this case, Alyssa?
56 at x to the 6
Mm-hmm.
and y to the 4.
Very good. 56, x to the 6th, y to the 4th. So remember how we were putting everything in order from biggest to smallest? That in that case, the bases were the same, right? They were all x's? Yeah. In this case, we have x's and y's, so we put them in alphabetical order. Okay? Okay?